So in this video, I want to explore what happens when we have something like 7 cubed divided by 7 squared. Now, the first thing I want to make sure we're clear on is that that means exactly the same thing as writing 7 cubed over 7 squared. These two notations mean the same thing, and quite often as we get stronger in our mathematics, we adopt this much more than we do the division symbol. The division symbol really starts to kind of get forgotten the higher the mathematics that you go, and we try and utilise fractions instead. So 7 cubed over 7 squared is the same thing as 7 cubed divided by 7 squared. Now we know what 7 cubed and 7 squared are. These are 7 times 7 times 7 and 7 times 7. Now here we have a number that's in the numerator that's been written as the product of its prime factors, 7 times 7 times 7. And we also have a number in the denominator which has been written as its product of its prime factors, 7 times 7. Now the thing is that both the numerator and the denominator have common factors. They both have 7s as common factors and also another 7 as well. So they both have 49, 7 squared as a common factor. So what you can do is you can say, well, this fraction is not in its simplest form. You could divide top and bottom by 7. You could do it again. You could divide top and bottom of the fraction by 7. Now what you would have left is 7 in the numerator and 1 in the denominator. Okay, so I've divided 7 times 7 by 7 times 7, and that's reduced it to 1. And so I get left with 7, which I must understand is the same as 7 to the power of 1. Now, in our process from the starting question to the end, what seems to have happened is that I had 3 7s in the numerator, 2 7s in the denominator, and then I did 3 take away the 2, and I got reduced to 1. Okay, so let's see another example. What about if I had 7 to the power of 5 divided by 7 to the power of 3? Now this is the same as 7 to the power of 5 over 7 to the power of 3 using the fraction notation. And so we have 7 times 7 times 7 times 7 times 7 in the numerator over 7 times 7 times 7. Now we can divide top and bottom by 7, and then again, and then again. And what I'm left with is 7 times 7 in the numerator, which is 7 squared, over 1. And so we have 7 to the power of 2. So 7 to the power of 5 divided by 7 cubed is the same as 7 squared. Now, so what we're seeing is that when you divide with the same base number, we subtract the indices. And the order matters. We're doing 5 take away 3, not 3 take away 5. Okay? So we can generalise this to say that if you've got b to the power of x divided by b to the power of y, which remember is the same thing as b to the power of x over b to the power of y, we can write that as b to the power of x take away y. So this is an index law for division. Okay, much like we had for multiplication, but now we know that if we have division, we can subtract the indices.